Okay, once again, good afternoon, gentlemen. Today, I'm going to discuss to you about basic electrical safety. Okay, in this topic, I will discuss commonly used electrical terminology, and also I will discuss about the DC and AC. I will discuss also the different types of electrical good conductor materials and non-conductor materials. And also I will discuss on how to recognize the electrical hazards, and I will give you some example of electrical signage. Okay, then before I proceed, let me shout out to all our barangay officials in Barangay 905, such as Chairman Telma Sambrona, Kagawad Edwin Sambrona, Kagawad Ariel Himan, Kagawad Darwin Peregrin, Kagawad Boboy Di Pedro, Kagawad Biron, Maring Pat Villarin, and also shout out to my loving housewife, Miss Luisa, and sa aking mga anak, Obet, Jason, Robilu, and Wetty. And special thanks to all friends of Wetty for supporting my channels and for subscribing to my channel. And also shout out to all Batang Punta, Laking Punta, and also shout outs to all my idol, Engineer Rodelio Canon, Engineer Ray De Elio, Engineer Jerby Intig, and Engineer Elmer Lamis. And also shout out to all my Tito and Tita, Tita Baby, Tito Jimmy, Tito Atoy, Tito Bay, Tita Inday, Tita Belen, Tita Toreng, Tita Nida, Tito Henry, and to my nanay and Tita Malu. Shoutout po sa inyong lahat. So nawa ay nasa mabuti kayong kalagayang lahat. So shoutout also to Mr. Ranjit Mukia and to Mr. Roldan Manabay for continuously supporting on my channel and continuously watching on my channel. Thank you very much for your subscription, and just continue watching on my video, and I hope you will learn something in this video. Thank you very much, and let us proceed to the topic. So, good morning, gentlemen. Our topic for today is about basic electrical safety. Okay, so to start with, I show you this electrical terminology, okay, which commonly here in electrical circuits. Okay, electric current is a stream of charged particles such as electric ions moving through an electric conductor or space, and the unit used for measurement is amperes. Okay, second is the voltage. Okay, voltage is the pressure from an electric circuit power that pulls charge of electrons, which is the current, okay, through a conducting loop. Okay, then the unit used for measurement is volts. Okay, next is resistance. Resistance is instance of opposing. Okay, the opposition offered by a substance to the passage through it of an electric current. So in the resistance, this one is avoiding the electric current to go out from the good conductor of the electricity, which is our copper's cable. Okay, so that is the resistance. Then what is the conductor? Conductor conduct electrical current very easily because of their free electrons. Okay, So the current can easily flow to this conductor because of a million free of electrons. Okay, so insulator. Okay, electrical insulator or non-conductor materials that does not transmit electrical current. Okay, so in the insulator, current is not possible to go out through these materials. Okay, so in here, as you can see, we have here electric circuits. Okay, as you can see, this is our battery. Okay, which serve as our source of electrical energy. Okay, this is our electrical cable, which is our good conductor. This is our switch, and this is our loads, the bulb, incandescent bulb. Okay, because of the different potential given by this battery, and the volts, pressure is pushing the current, no, to flow in this conductor. Okay, once this switch is in off position, the electric current will not flow continuously. The electric current will stay only up to here. But if you put the switch in on position, so the current will flow easily going to the loads. Now, when he reach these points, our light now will light up. Okay, because of the current. Because in here you will see the current is just continuously flow. Okay, but in here there is a switch. So once you off the switch, current will stop in here. Okay, so that is the example of a simple circuits. Okay, here this is the direct current. Okay, direct current is a circuit that electric current flows through in one direction, and the good sample of this is our battery. Okay, next, this is the sample of an alternating current. Okay, an electric current that reverses each direction many times at regular intervals. This typically used in power supply. Okay, as you can see, we have here a transmission line. Okay, from this transmission line, it is distributed to our houses or our home. Okay, so that is a good example of an AC or alternating current. Okay, now what are the materials which is good electrical conductor? Okay, in these materials, the electric current can easily flow. Okay, so these are silver, gold, copper, steel, seawater, aluminum, iron, concrete, and mercury. Okay, then the commonly used in commercial area, okay, to use as electrical conductor, as you can see, usually is copper. Okay, but also they are using aluminum, especially in the primary line of the high tension. The other materials is cannot, they are not using because of the the prices, no, and the characteristic of the copper and aluminum is more cheapest and easily used. Okay, our next is, what are the materials which is non-conductor? okay, or a good insulator, okay. In here, rubber, plastic, glass, oil, diamond, dry wood, dry cotton, porcelain, dry paper, fiberglass, asphalt, and air, okay. But usually they're commonly used as a good insulator, especially in our cables or wires. They use rubber, okay, because of the cheapest price and a good characteristic of the rubber as insulator. Okay, now we proceed now to the topic proper. Electrical hazards, okay. These are the sample of electrical hazards which you usually you can recognize, okay. So first is electric shock, burns, arc blasts, sometimes the pole, fires, and explosions, okay. Electric shock, okay. Electric shock, an electric shock occurs when a person comes into contact with an electrical energy, okay. Sometimes when a person touch or have a contact with the live electrical energy, sometimes there is no injury at all, but most of the time it's result a devastating damage or death, okay. As you can see in this picture, this person is trying to hold or having a contact with this open and live panel. So in these things, his fingers is can touch the live wire. So if he touch the live wire, the current will easily flow to his body through his finger, which is touching the live current, okay. So it will cause him an electrical shock, okay. Then okay, electrical shocks, no, electrical shocks, how electric shock affect on the body, okay. So at 1 to 2 milliamps, it will give you a painful shock. 6 to 10 milliamps, minimum let go threshold for an adult. Then 10 to 20 milliamps, a possible seizure at the contact point, okay. Electric shock may directly cause death in 3 ways, okay. Number 1, paralysis of the breathing in the brain, okay. Paralysis of the heart. Then ventricular fibrillation. Ventricular fibrillation is uncontrolled or extremely rapid twitching of the heart muscle, okay. So that is the cause of the death of the people, okay. Then here, as you can see, is the sample of an electric burn, okay. An electrical shock may cause burn, okay. Sometimes it will leave no visible mark on the skin. An electrical current passing through the body can cause damage inside the body, like cardiac arrest or other injury. Under certain circumstances, even a small amount of electricity can be fatal, okay. So here in this picture, this person is having a contact with an electrical current. Okay, another sample of electric burn. This one, upon contact with a high current, so as you see, his hands is damaged. Okay, then another electrical hazard is arc blast. Okay, arc blast, explosive burns of energy that occurs during an arc blast. Okay, you see, there's a personnel there. Then he's trying to work in the panel, but upon opening of the panel, the arc blast is happened. So it is one of the electric hazard, arc blast. Okay. Then next hazard, electrical hazard is fall down. Okay, because of the electric shock of a person, the instinct reaction of a person who have a contact into a live wires is to remove his hands from the contact into live wires. Then because of that, maybe because of the loss of balance like that, so it will result to a person to have fall down. Okay, now here, fires and explosion. Okay, it happens if we leave our appliance, okay, unattended. Okay, if our appliance is left as unattended, so there is a chance of overheating. So it will result of the fires, and next is explosions. Okay, like in these samples. Okay, as you see, the electric iron is leave unattended into this iron table. Okay, and there's a cloth in on that iron table, so it will cause burn. Okay, it will cause fire. Okay, here in our next sample, too much cord plug into an outlet and leave it unattended, so it will cause fires. Okay, then if there is a fires and in an area where there is an explosive material or combustible materials, it will result to an explosion. How does current enter the body? Okay, normally, okay, the current will flow from our hands which having a contact to an electric current, or sometimes from our feet which is having a contact into a ground which having a flow of current. Okay, how does current flow to the body? Okay, electricity current flows the path of at least resistance. Each of our body is mostly water. The conductivity of water is how all life function. Okay, so because of our body is composed of mostly water, then this current will easily flow to our body. Okay, by having a contact from a live electrical circuit. Okay, current travels the path of least resistance to complete its circuits. Okay, because of our rings, because of our watches, and it's having a moisture, so it's giving now less resistance to our skin, so the current can easily flow through that path. Okay, this path could be through upper limbs or between upper and lower limbs. Okay, so from our finger, through our hands, going through our upper limbs and sometimes between upper and lower limbs. If the current is flowing to our heart, that is the most danger part, okay, because it will kill you, okay, because if the current flow to our body and to our heart, and it is affected our hearts, and the heart is stopped, our heart will stop functioning to give air into our brain, so it will cause death. It will cause the people to be dead. Okay, as I said, this includes the heart and respiratory system. It can result in serious injury. Okay, so it's clear. Now, here we go to a hazard recognition. Okay, I will give you a sample of some electrical hazards, and we will try to recognize what is the hazards involved on that sample. Okay, what are the things to check, okay, in recognizing the electrical hazard, okay, in either this is unsafe condition or unsafe act. Number one, this is a checklist, okay. Wiring method is of approved type of the purpose, okay. Cable insulator has no signs or damage or deterioration. Electrical equipment, cords, plugs, cable has no sign of overloadings. Switches, devices in good condition or insulation. Grounding of an electrical equipment is properly connected. Hazardous materials is stored near equipment, live lines, devices. Danger signage, permit, clearance, hold tags is available. Okay. Now, in this first picture, okay, you see, this is our tracking, and you will see a bunch of cable inside raceways, okay. So try to recognize what is the hazard here. First, checklist. Wiring method is of approved type for the purpose and location. Okay, so no. Aside from a different type of cable run in a trunking or the raceways, the cable are already damaged, and maybe the rod or the insulator is already old. Okay, so maybe that is the cause why this insulation is like this. Maybe the rod white this insulator, or maybe because of too much long period of time, the insulator now is easily damaged, no, because of the lifespan. Okay, has no sign of damage or deterioration. So yes, there is. Okay, panel boards and electrical equipment cords, plugs has no signs of overloading. Okay, maybe why this insulator now is like this, maybe because of the overloading, because if your wires is overload, so this cable will become hot. Okay, so maybe this insulator is melt because of the overloading, so that is very dangerous. Okay, then safe working practice follow. So as a safety officers, when you notice a hazard like this, call immediately the attention of the skilled person, or report to immediate supervisor to correct these things, or to isolate this one, modify this one, to remove the hazard in an area. Okay, second sample. Okay, in here you will see that there is a conduit, and this bunch of cable entering to conduit, and this is a metal parts. There's a metal parts. Okay, so wiring method is the approved type for the purpose? Okay, so no, because as we all know, there is only limited cable, okay, that can be put into a conduit or a raceway. But in here, obviously, you can see they trying to pull too much cable into a raceway or into a conduit. Then by that, it will cause overheating because he is now occupying all the space of the conduit. He is limiting now the space of the conduit, and as you will see, as you notice in here, there is already a kink. So this is the signs of the insulator is damaged because of these metal parts. Okay, so that is the things that we observe. Next, you see, this is an electrical panel. Okay, number 1, checklist. Wiring method is of the approved type for the purpose? No, because instead that the wires is properly connected to a circuit breaker, it only did a temporary splice of the wires. See, he did only the temporary wiring and connection of the wires, instead putting it correctly into the circuit breaker. Okay, insulator has no sign of damage or deterioration. Okay, no. You notice that one of the wires, the end has no electrical tape. You see here, one of this one is no electrical tape, but it is connected into a live wire. So somebody touch this end, it will cause him electrical shock. Okay, we go to the next sample. Okay, you see here, too much socket outlet, try to plug into an extension cord, then try to plug too much socket, too much plug. Okay, so wiring method is of an approved type for the purpose? No, too much plug octopus wiring can be cause overloading of a circuit, because you know this extension cord or socket outlet is designed for a purpose only, but you are using it more than for the purpose, it will cause overloading. Okay, insulator has no signs of damage. Okay, cable shall be properly dressed and will arrange to avoid easily contact to a damaged wire or cables. Okay, so what you will do here, call again the attention of the skilled electrician, or report immediately to a immediate supervisor to do a correct ways of this one. They will arrange it properly to avoid short circuit in these things. Okay, here you see, this is a funnel wherein our cable is connected. As you notice, the cable wires is already burned. So by that, it will cause short circuit and overloading. Okay, and this is very dangerous to a person who having a contact to these open wires. Next, you see, the rat is bite the insulator. That's why don't leave any extension cord or use any extension cord to be permanent. Okay, because it will happen like this, that the rat is bite our extension cord. So if it's happen like that, it is very danger. Okay, now We go now to the for the familiarization of our danger sign. Okay. Danger, life apparatus. So this signage you will put in an area where there is a life equipment or apparatus. Okay, to give notice to passers that the apparatus is live or energized. Okay, caution, do not interfere. To alert all passer or co-workers not to interfere in the equipment in the area. Okay, so you will put this signage. Single pit circuit, no work allowed. Okay, to avoid anybody or an authorized person to work in an area or place. Okay, then next is working area. To notice the passers that the place is a working area or somebody is working in the area or space. Okay, here you see they put this signage working area. Then in the working area they put this barricade. Okay, so now this area is safe to work. Okay, and the other end you see this disconnect is locked. Okay, so that somebody will not easily on or energize these points, same as the other ends. So if it's like that, because if you put the lock, there is no chance that other personnel can energize this one because you have the key. Okay, so by the things, this area is safe to work. And you see danger apparatus, live danger live apparatus. So you put this area wherever there is a live apparatus. Okay, next, see, you can put also this signage if there is a presence of electrical shock or an arc blast. Okay, now most of the people, okay, an average of a person is thinking that the voltage is the one who killed the person, but the reality, the current is the one who caused death. No, electrocution is death caused by the electric shock. Okay, so what is your role as safety, no? As for safety? So your role is to start recognizing the hazard in your workplace by going around and look for unsafe condition, unsafe act. Okay, report all safety violation and have them immediately corrected before an accident occur. So be sure that the hazard that you identify shall be corrected or eliminate to avoid accident that caused by that hazard. Okay, so what next? What action you will take? Okay, so enforce company safety procedure, report and correct safety violations or accident, and be a safe model. Okay, that is the action that you need to do. Okay, if you observe a safety violation, you should stop the violation if possible. Okay, second, report the situation to the supervisor in charge immediately. Okay, then record the details in a report form. Give copies of report to the concerned supervisor or manager for immediate action. Then follow up with the supervisor of what is the action being done. Okay, so first, if you notice the electrical hazard or electric hazard, try to stop the violation if possible. But if it's not possible for you to eliminate the hazard, make a report. Okay, then call the attention of the supervisor, record all the details in a report form, then give the copy of the report to the immediate supervisor or manager and ask them for an immediate action. Then follow up if the hazard report is corrected or modified or eliminated. Okay? So, any questions? That's it for now because our time is too much now. And maybe you're going to be tired if I continuously this for 1 hour. Okay? So, I decide to cut up to here only. Then I'm trying to make a second part to show to you or give to you some more idea about the basic electrical safety. So if you have any questions regarding this topic or any suggestions, you can make a comment to this video, okay, or just message me. Then I'm with all my best. I'm trying to answer all your questions with all my best. I'm trying to do more videos and for the benefit of those who need more information or additional knowledge. Okay, so that's it for now. Thank you for watching. If you're not yet subscribed, please subscribe on my channel. Maraming salamat po and God bless all. Thank you very much.